Hello, this is Greg Wagner. I'm going to make a real quick video on using random access files, and you can actually see more random access files. It's better random access file examples in the notes for the assignment, for assignment 10. But I just wanted to quickly kind of go over, just talk about the different parts of it. So I've already made here a main file, and in Java, in Eclipse. And so basically the main thing you're going to do is you need to open a file, modify the file, so this includes read and write, and then close the file. And random access files basically means you can jump anywhere you want in the file, jump around from the top to the end of it, and randomly pick data out of it. And that's why it's called a random access file. It acts like kind of like memory, where you can jump anywhere into it. Whereas sequential files, kind of the ones we dealt with the last assignment, where we start at the beginning and kind of go through it. And so, kind of the main things are, so opening a file, we're going to need to import out of Java I/O random access files. And then to open it, we have a random access file. I'm going to call this RAF equals new random access files. So with the new, remember we're allocated memory. And this also is the constructor we're also opening it. And so I'm going to just call this one test.dat as the first argument. So the first argument is going to be a string value of the file you're going to want to read or open. The next one's going to be the mode. So I'm going to do RW, which stands for read write. If you just do R, or by default, it just means R means you just read it, and then W means write. So we're going to read and write for this file for the assignment. Do read write. And then for random access files, you need to have a try catch along with it. And my kind of perspective is anytime you have a user or kind of any type of interface with the outside thing, I always do a try catch, basically because you never know what people are going to do. And since this is an I'm going to actually make this a try catch. I'm going to put the random access file outside of it and just assign it with a null. You could also use this as a class property. And then one of the reasons I like Eclipse is it kind of can build some of the stuff for you, or at least tell you what the issue is. And so I can't remember what the error is for this, but I can see it out. So what the error would be if I don't do it. So if I put my mouse over a random thing, I can see the exception here. So it's going to be a file not found exception. So I'm going to do try catch, and for the catch value, I'm going to do file not found exception, just to call it E. And so I'm getting an error here because the file isn't existing, so I need to import that. So I can import it in the same package, java.io file not found exception. And I'm just going to write out here system.out.println file could not be opened. And then since it's killing the program, I'm going to do exit, or actually return. And this will, since we're in the main level, it will allow the file to quit. And so this is kind of just a habit I like to do, is whenever I open a file, I always like to set the close right away. The reason why you want to close files, even at the close of a program, this needs a throw catch around it as well. So I'm going to use the key thing and say file could not be closed. So just basically cutting past the things here before. I have an IO exception for this above one here, and I brought it in when I did the Eclipse stuff. Again, this is another reason why I like Eclipse. But the reason why I always like to do the close a file as soon as it's open, just so I remind me to do it. And what happens is if you don't close a file during the during program running, after it ends, it eventually the operating system will free up the file descriptor. Basically, an operating system only has so many files it can open at one time, and as you use one, basically it's one less you can use, and you have to close it. It frees up that allocation of files you can open, so the operating system can open more of them. So I like to close them as soon as I'm done with it. For this class, I mean, you're not going to open a whole lot of files, but some other programs you have lots and lots of files, and I kind of keep the file descriptors kind of small. And this is the number of file descriptors, not just for their program, but it's for all the programs on the computer. So if you're doing a lot of file stuff, say like you're doing some simulation work, where you have like multiple processes running at the same time, this could be an issue. So now that you have the open close, we're going to do the read. So before you do the read, you actually have to, for random access, you have to actually put the cursor where you think it is. So for this assignment, what you're going to do is put the cursor at the location. So initially for reading, you want to put it at the start. So I'm going to put it at the start, RAF, and then seek is where it's going to be. So if I put seek 0, that means we're at the start. And again, we need to put do a throw. Let's see what one this is. IO exception. So we're going to put IO exception case around this. And this will basically kill it. So I'll put a little message in here. Usually with IO exceptions, you always want to put a message as well. Generally for this, if you get an IO exception for seek, it generally means the file can't be opened or something got corrupted with it as it's running it. So it's not a huge deal. And here you get a warning saying it's not going to close. So what you might want to do is have a close after all this seek stuff. Or we can also do is kind of get rid of all of this junk. Is do the throws IO exception top here, and then this won't be necessary. Generally, you put this around the methods that we're calling these particular, these other open-close methods. But I think just to make it so I don't have to do it for all of them, I'm just going to put the IO exception here, but which is not the best case, but it's something. So if I want to write, so I'll do RAF, write, and then I want to put, I'll do write. Int, and let's see, I'll put an int up here. This int val1 equals 100, and then I'll put val1 in here. This will basically write val1 to the file, and then you can do this for all the other ones. And then for reading, I do RF read. I'm sorry, do RF seek again. So basically put you back to the start, and then I could read from RF read int. And what this will do is, since this is an integer up here, basically the integer is 4 bytes, and this will know to read 4 bytes off the value and then put the cursor at the end there. And so this is going to return an int value, so I can call this RAF int val2, and if I write the value out, it should be at 100. And so the example included, that was actually from one of our retired employees. Fred D'Angelo has additional stuff in there. And so basically for this assignment, he has worked hard all semester, is basically just basically modify the code that I give you, or that's given to you for the assignment. And so I'm going to post this code, and then if you have any questions, just ask them in the discussion or email me.